So in this video, I'm going to give an introduction to the SQL query language, and specifically the T-SQL variety. And so we'll talk about what that means here in a second. So first, let me just share the PowerPoint. What is SQL? So SQL SQL, and I know there are two camps of pronunciation on this. I personally say SQL, others say SQL, but SQL or SQL is an acronym for the Structured Query Language, which was a language developed in the 1970s. So it's been around for quite some time. And the language, the purpose of the language is really to access or quote unquote query stored data within a relational database management system. And relational models for database management really follow this idea that you can have these disparate tables stored within a database, but that they can somehow be linked. And the reason that you want to separate data, right? I mean, in an ideal world, you would have one table with everything you need in it, all the data you could imagine or ever want. But what happens is, if you in practice, that kind of data, that kind of table, that kind of information is difficult to store, because the width and the height of the data kind of have multiplicative or exponential ramifications for the size of the data, and so it strains computer resources when data are ultimately stored that way. And then the other piece to that is not only storage, but also the amount of computing power that is needed to query that data, to pull it down, and to manipulate it. So the relational model really has these different tables that are all quote unquote related to one another. And the way that you combine these tables is through the use of keys or unique identifiers. So for example, you work at a bank, right? And you have this customer information, different parts of customer information stored in different tables. So one table might have, characteristics of a customer's loans. Another might have another table might have the customer's address or contact information, and then others might have more information about the loans themselves. But ultimately, you can link all this information together through keys. So an account number or a customer number, or a loan number or something along those lines. And so that's really the framework for the relational model, but also for the SQL, which is used to ultimately work within that relational model. So you'll notice that I'm going to always call it SQL in this course. I'm not going to say T-SQL, but you'll notice that in most places where I call it SQL, I put the T in front of it. And so that T specifically means transact. And we'll talk about why that exists. So a SQL by itself is kind of a universal query language, and it really is kind of the building blocks of a query that you might write to access data. So there's get me this data, use this filter criteria, right? That's what the language or the query is saying. But ultimately, the SQL language doesn't have, larger programming capability built in to the language. And so there are these various procedural extensions. So T-SQL is a procedural extension to the SQL language, that allow you to work with the SQL language, but add more programming functionality to it. So for example, you have stored procedures. You can run procedures. You can loop, which isn't just a built-in functionality to SQL. You have to put something on top of SQL in order to be able to do that kind of stuff. And so, and that's kind of the last bullet here. By itself, SQL can only be used to query data. So the extension, the T-SQL extension, and there's a variety of them, I'll talk about that in a second, allows you to program program procedural elements like functions or logic or loops or anything that you can really do with a programming language. That's what the procedural extension is for. And you won't actually see SQL in practice like the base SQL. You'll see a procedural extension. So T-SQL is one of the possibilities that you might see in the workplace, and that's really the Microsoft version of the SQL procedural extension. And that's for use with a SQL server, a Microsoft SQL server. So really, the procedural extension you use is ultimately to how the data, what kind of server you're using. And so there's an Oracle version, which is PL SQL. There's also an open source version. And then honestly, there's quite a few, at least 20 that if I go to Wikipedia and pull up a list, there's probably 20 of these things. But for the purposes of this course and what I'll talk about is we're really talking about T-SQL. And why does that matter? Well, these procedural elements that you put on top, functions, logic, loops, things that aren't built into the SQL language. Well, the developers at Microsoft chose to do things slightly different than the developers at Oracle. So it's a nuisance if you're working between the two, because doing one thing in in T-SQL might be slightly different and enough to be annoying. But if you were to do that in PL SQL, so just keep that in mind. We'll be talking about T-SQL. If you encounter an environment that's using something else, it's more likely than not that you'll have to search some resources on if I do this in T-SQL, how do I do it in PL SQL? So next slide. Just to talk about programming languages in general and how kind of the SQL language, and I'm talking about T-SQL here, how a procedural extension, how that fits within these programming, these larger kind of programming features or features of programming languages. Programming languages most always have an ability to comment. So what does that mean? You can essentially use symbols to tell the compiler or the process that runs the code to essentially not run one or more lines or portions of the code. And so those portions of the code are quote unquote commented out. And so there's symbols. All the symbols vary depending on the language you're using. But at the end of the day, you're able to comment out code. And this is useful for a couple of reasons. A, when you're revising code, and you might need what was originally there, and you're making modifications, testing modifications to it, and so you don't want to just completely wipe that away. It's also useful for notes to either someone else who might encounter your code down the line, such as a validator or a future employee, or even just a colleague if you're working on a team, or your future self. So there are many times where I have code. I know it's there. I know that I did this a year or two ago, but when you open it up, it sometimes saves you time if you comment specifically what you're doing or what elements you need to change if you're gonna update specific data. So comments is one thing that all programming languages have. I put all in quotation marks and not here, but it might be the case that one programming language out there, because there's so many, right, might not have the ability to comment. But I mean, for all intents and purposes, this is pretty common. The other is all programming languages have some sort of case sensitivity. And what I mean by that is some languages are fine if you use a capital letter or not. But some, and that's called not case sensitive. So it doesn't care whether the programming language or the compiler doesn't care whether you capitalize or something. There's no distinction between a capital S and a lowercase s. There are languages, and so SQL is one of those languages, T-SQL. It does not care, right, if you say select and all uppercase letters, or if you have some combination of uppercase and lowercase. So T-SQL is not case sensitive. There are plenty of languages out there that are case sensitive. R is a pretty common example, and that can cause a lot of headaches if you're going from one language to another. Just always need to remember whether or not case sensitivity could feature into your programming and potentially errors and that sort of thing. The other really important part of programming is data types. So this is really how data is stored and treated by the programming language in memory. Or within a table, specifically, talking about T-SQL. So a number is stored and handled differently than a word, or which is referred to as a string. And so, you can do operations on numbers, right? You can add, subtract them. You can't, you're likely to get an error if you try to add or subtract a word or a string. And speaking to that, most programming languages have operators, so you can add numbers, right? You can subtract, divide. There are also operators with strings, so you can pull the first three characters of a string. There are other string operators as well. Concatenation is a common one, so you can pull elements of two strings and put them ultimately together into one string. And then to continue the list, most programming languages have conditional logic, which is really if-then. So if this condition is satisfied, perform this action or don't perform some action. And then otherwise, do this. And if-then logic is really a foundational component of programming, because that's what programming is for, to give directions, right, to the compiler or the process that's going to run the code. The other piece is functions. So, it basically transforms an input into an output. And these are as simple as some aggregation functions like summing or averaging over a list of values. You can also, with certain functions, you can also, I'm trying to think of something that's different than an aggregation function, but you can also ultimately do take an exponential, take a logarithm of a number, or calculate a percentile for a list of numbers. And so there's various types of functions. There's functions also with strings. So what I was talking about before, when you pull those three first characters of a string, that's probably going to be in a function, not an operator. But the same idea applies. You can do things, right? You can manipulate numbers and words. Then the other piece of programming language that's common is loops, and so it's executing the same. It's an iterative process. So you're executing the same portion of code, but essentially changing the inputs or the thing on which that code is performed. So an easy kind of example to understand is with Microsoft Excel. So if you were to loop through every cell and add 5 to the number that exists in there, the loop would start, say, first cell in that group, add 5. Then it would go to the next cell. And so that's the loop, right? It keeps on circulating through every cell in that group and applying the same add 5, add 5, add 5. And so that's really the iterative nature of a loop. And the reason that loops are useful is that they're efficient. So if you need to do something a lot of times, loops are usually built in such a way, or can be built in such a way, that they're very, very fast and efficient. It's usually much more efficient to use a loop when doing something large scale, which requires a loop, versus programming it without one. And then the last thing that is common across programming languages is syntax. And what does this mean? It means that a programming language will have a specific way in order to tell the compiler or the process that runs the code how to do something. And so, for the syntax is essentially the various keywords and structure of a language, of a code chunk that ultimately performs some action. So, for example, I'm trying to come up off the top of my head with a SQL analogy, a SQL kind of R analogy. And SQL, you'll tell, telling, just the very basic pulling data from a relational database. In SQL, you're going to basically use the SQL language, and that's a query, right? But in R, you might have to, have these various elements or syntactical elements in order to first write some sort of query, then send that query out through, from R and pull that data back in, and then you might ultimately need some language or some code to tell R, how to treat certain data types, etc. And so the syntax is really what makes programming languages look and feel different, even though they're, for all intents and purposes, in most cases, doing the same thing. Another probably easier example to interpret is really SAS versus R, right? And if you're going to run a regression on the same data set, the way that you do that, the syntax needed to do that in SAS versus R is very different. But at the end of the day, you're running a regression; it should return the same results. And then, to talk about SQL specifically in relation to these other languages I've thrown out there, R, Python, SAS. The purpose really of SQL is different ultimately and more focused than your R or your SAS or your Python, or frankly any other general programming languages that are out there. So for SQL, really, the sole purpose is data extraction. You can also do more, right? Manipulation, data exploration, data creation, management. All those things that come with data. But data is the purpose of SQL. The purpose of SQL isn't to run an estimation procedure to come up with estimates for a regression. And so that's really what it differs. That's its focus. And so that limits it, right? That you can only do certain things with SQL, but at the same time, it can do a lot of things that it can do a lot of things with data and very, very efficiently. And so that's really why it's the foundation for data extraction from relational databases. And so really, the framework for SQL that I like to think about is that there are really these two kind of uses for it. And this is just from my own experience, right? So SQL, in my personal experience, SQL is usually used for kind of ad hoc analyses. So, right, you'll get a question for management, just kind of a fresh question that wasn't necessarily answered before, or was answered before, but they want to look at it a different way. And so ultimately, you got to start with your data in order to answer the question, assuming it's a data-driven kind of question, or a question that requires a data-driven answer. So you'll start with your data, and you'll have to, write queries to essentially pull data down that you want. And the query can be as simple as, give me this data, start big, and then you can filter it in Excel, or you can, manipulate it in Excel, right? But SQL allows you to do all that functionality as well. So it's far more efficient, right, to get your data and cleaned, transformed, and in a form that you can ultimately start your analysis, from the ground running once you pull it down from your query. An example is, someone might be interested in, if this reporting isn't standard, how many loan applications for the current month have been rejected. So I work at a bank. They want to know, okay, in this month we had, call it 100,000 applications. How many of those applications were rejected? And so, if that question hasn't been answered before, if there isn't a report for that, you've got to go to SQL. You've got to go to the data, usually extracts from various systems, and then you've ultimately got to write a query in order to answer that question. And so this really will be the focus of the course. The other component, the other kind of, I guess, a level above, right, that kind of analysis is, what if management wants to know this every month, which is perfectly a reasonable request or assumption. And so for that, really, you start to talk about like programming a procedure, a stored procedure that will run every month and answer this question, right? And ultimately may support some reporting that a group has, or et cetera. And this is really on the automation side of SQL. And frankly, what you need the procedural extension for is looping, right? And a lot of, if this, then begin this step, and that sort of thing. But we're not really going to go, may touch on certain elements that you would need for those kinds of applications, but this is that portion of SQL and data management and automation, report automation, query automation is kind of going to be outside the scope of this course. So with that, I think that's the end of this slide. And in the next videos, we'll jump into the SQL query and explore its syntax, its features, etc.